The solution of this problem contains one of the most important ideas from algebra. Even though the problem looks very complicated with cubics and square roots, it's possible to avoid doing complex calculations when proper tools applied. Also, there is an extra practice challenge in the end of the video. Try to understand the idea and solve the challenge at the end. The main problem in this question is the cubic roots. How to work with cubic roots? Can you take cube of the expression to deal with the cubic roots? The formula for a plus b cubed is the following. If you use this formula, you have to do complex calculations. We don't really want to do these calculations. Let me show you something even more complicated. Sum of cubes of three numbers minus 3 times abc is going to be a product of the following two expressions. The first one is a plus b plus c. The second one is the following expression. This definitely looks worse. But what if the sum of three numbers is 0? Then everything in the right of the equation becomes 0. That's because we will be multiplying by 0. So this is our big idea. Whenever you have three numbers whose sum is 0, then the sum of cubes of three numbers is going to be equal to 3 times the product of these three numbers. Let's save this as a property, and we are going to use this to simplify our initial expression. Now let's go back to our initial expression. Let's set this expression to be equal to x. And by treating everything as an equation, we can try to find x using the property we just learned. Here, if you take the x to the left, you can see three numbers whose sum is 0. This is the first number, second, and third number. When the sum is 0, we can use our property. In our property, on the left-hand side, we had sum of cubes of three numbers. So let's write the sum of cubes of these three numbers. Cube of first number plus the cube of second number and plus the cube of third number. Here, note that the third number is negative x, not just x. That's why in front of the third number, we have negative sign. So the sum of these three cubes is going to be equal to 3 times the first number times second number times the third number, which is negative x. Now let's simplify everything. Here, cube cancels the cubic root. And here as well, cube cancels the cubic root. And for this expression, we can write everything under one cubic root. With simplified terms, we will have 2 plus square root of 5 plus 2 minus square root of 5 minus x cubed is equal to minus 3x, and under the cubic root, this expression. Roots of 5 will eliminate each other, and this expression under the cubic root is 2 square minus root of 5 square, which makes negative 1. On the left, we will have 2 plus 2, 4, and on the right, we will have negative 3x multiplied by negative 1, which is just 3x. Finally, we have something very simple. This is a cubic equation. So if I find x from this equation, and recall that x was equal to our expression from initial problem, so that would be answer to our problem. Let's rewrite the cubic equation in this form and try to find x. We will simply factorize the equation as follows. Rewrite 3x as minus x plus 4x. Now you can take out 4 from these two terms and write it like this. Also, you can take out x from these two terms and write it as this. X squared minus 1 can be factorized further. Now at this point, you can see that x minus 1 and x minus 1 are common terms, which you can take out of the parentheses. The factorized form of the equation will be x minus 1 multiplied by x squared plus x plus 4 equal to 0. Now we can solve each of the factors separately as one linear and one quadratic equation. It's very easy to verify that the discriminant of the quadratic part is less than 0, which means it has no real roots. The only real root of this cubic equation is x is equal to 1. Knowing that x is equal to 1 and our expression is equal to x, we can claim that our expression is equal to 1. This was one of the simplest ways to solve this task. In fact, This identity is widely used in mathematical contests. That's why it's worth noting this identity. If you want to do more practice, you can try to simplify this expression using the same idea.